Hello friends, I Dr. Minal Harde from Department of Pharmaceutical Chemistry, PE Society's Modern College of Pharmacy, Nigri, Pune. Welcome you all in today's section. Today we are going to see in detail on topic turbidometry and nephelometry. Mostly turbidometry and nephelometry, this technique is useful for analysis of suspensions. Nephelometry, this technique is based on scattering of light. When scattering of light is measured, in the turbidometry technique, transmitted light is measured. When light passes through moderately stable suspension, then a proportion of incident light or radiant energy get either absorbed, reflect, refract or remaining get transmit. Optical characteristics of each suspension shall alter according to the concentration of dispersed phase. In nephelometry, the measurement of intensity of scattered light as a function of concentration of dispersed phase forms the basis of nephelometric analysis. The amount of radiation scattered by particle is measured at an angle 90 degrees to that of incident beam. Turbidometry, in this technique, the measurement of intensity of transmitted light as a function of concentration of suspended particle forms the basis of turbidometric analysis. The amount of radiation scattered by particles is measured at 180 degrees to the incident beam. Then the turbidometry technique, it is very much resembled with the colorimetry, and this nephelometry technique, it is very much resembled with the colorimetry technique. This is the diagram in which when we are passing the light or radiant energy to the suspension, we are observing scattering at particular angle is seen or represented. Now we are going to see the theory. So in nephelometry, it is applicable for lesser concentration or less turbid suspension. So here in nephelometry we are getting very uniform scattering. Then intensity of scattered light is proportional to the concentration measured at 90 degrees. So scattering is measured mostly at 90 degrees and applicable for dilute suspensions. In turbidometry, it is applicable for concentrated suspensions or turbid suspension. So here scattering we are not getting uniform, as turbidity is more, so scattering is not very uniform. Hence the intensity of transmitted light is measured in this technique is at 180 degrees. Instrumentation. In this instrumentation we have the lamp, filters, sample cells and detector. Light source. Generally the white light or monochromatic light is advantageous or helpful for determination. One has to use high intensity monochromatic radiation, whereas short wavelengths are used to increase the efficiency of scattering. Mercury arc or laser beam with appropriate filter can be used, or for determination of concentration, polychromatic light such as tungsten can be applicable. Then detector. In nephelometry, photomultiplier detector act as a detector because intensity of scattered radiation is very small. In the photomultiplier detector, we have already seen cathode is present, anode is present and series of diodes are present. So from the single radiation we can generate a number of electrons. So multiplication of electrons is more, so amplification of current is more. So we are getting the better result at the very, or this detector is very sensitive. Hence we can use over here the photomultiplier detector. Then fixed. This detector is fixed at 90 degrees to the primary beam. In some nephelometer, detector is mounted on a circular disc which allows measurement at many angles, that is from 0 and from 30 to 135 degrees. In turbidometry, ordinary detector such as phototubes can be used. Then next is cell. cylindrical cells with flat faces where the entering and existing beams are to be passed to minimize reflections and multiple scattering from the cell wall. In general, cell with rectangular cross section is preferred, where the measurements are to be made at 90 degree. Octagonal faces will allow measurement to be made at 0, 45, 90, 135 degree to the primary beam. Generally, walls through which light beams are not to pass are painted a dark black to absorb unwanted radiation and minimize stray radiation. Then reflector is used which directs the scattered light to the annular photocell. Then photocell which convert light energy into the electrical energy and is recorded by a sensitive micrometer. Then some factors are there which affecting the measurement. First is the particle geometry. In nephelometry and turbidometry, most critical factor is the control of particle size and shape. The condition include concentration of reactants, temperature, agitation, pH, presence of non-reactants, temperature, order of mixing of reactant, and time allowed for particle growth. If one may not maintain this condition, one may get different size particle which may introduce major error in the turbidometry and nephelometry. Then next is the wavelength of incident radiation. In the wavelength of incident radiation is very important. In general practice, to select such wavelength where sample solution does not absorb strongly. In nephelometry, absorption is much less problem. Generally, white light is used as a convenience. Then RI difference, that is the refractive index difference. Best results are obtained when there is appreciable refractive index difference between the particles and its surrounding medium. Mostly in the nephelometry, the same configuration is there as represented over here. Lamp, lens, sample cell, and at 90 degree the detector is situated is the configuration for the nephelometry. But whenever the detector is situated at 180 degree means light is transmitting. So this is the arrangement for the turbidometer. Colorimeter, it is very similar to the turbidometer, and fluorimeter, it is very similar to the nephelometer. Then applications. It is used for analysis of water to determine clarity or concentration of ion. It is useful. Then for determination of carbon dioxide, we can use this technique. Determination of inorganic substance such as sulfate, we can use this technique. For determination of ammonia, we can use this technique. Determination of phosphorus is also possible by this technique. Then in the biochemical analysis also, this technique is very useful. Then for quantitative analysis, ppm level, we can determine by using this technique. Bacterial concentration also we can determine by using this technique in the biochemistry. Then water treatment in plant. Then sewage work, refineries, paper industries, in all this we can use this technique. In atmospheric pollution, smokes and fogs determination, we can use turbidometer and nephelometer. For determination of molecular weight of high polymers, it is little bit used. For phase transition studies, it is also little bit used. So this is the about nephelometry and turbidometry. Thank you so much.